So I decided I needed to remove the strut and replace it with a new one. What could possibly go wrong? Usually the propeller and the strut are both made out of manganese bronze, which is actually a brass, and protected from galvanic corrosion by the presence of several blocks of zinc or magnesium. The blocks protect those structures by dissolving themselves first. However, once they're gone, so is the protection. When I first saw Canis, the anodes were long gone, and judging by the number of creatures finding home where the anodes used to be, this situation had been going on for quite some time. Another clue suggesting that something was not quite right was a chip on the edge of the strut. At the time, I thought that someone had carelessly used a screwdriver to pry the catalyst bearing out, causing the edge to chip. I was wrong. Once I removed the strut, I could quantify the level of damage caused by corrosion. Here is a polished and etched section of the strut prepared after removal. As corrosion takes place, the zinc in the brass gets removed, leaving behind a brittle copper sponge, seen here as pink areas in the outside and inside of the strut. The gray ring in the center is a PVC sleeve I inserted to increase the photographic contrast. In average, about 50% of the wall has been compromised, and in some areas the full thickness of the wall has been corroded. Once I decided to replace the strut, my biggest concern turned into how to properly align the new one with the stern tube. After much thinking and considering different alternatives, I decided to go with a solid-state laser. With the propeller and shaft out of the way, I placed a custom-made bushing inside the strut and used the bushing to mount a laser aligned with the axis of the strut. I placed another bushing at the forend of the stern tube to reduce its diameter, making the measurement easier. For the actual measurement, I recorded the eccentricity in the position of the laser dot on the far end of the stern tube. To do this, I placed a piece of masking tape over the opening of the bushing to act as a screen. Knowing both the radial offset of the laser and the distance to the strut allowed me to calculate the angular misalignment between the two structures. Having a general idea of what I wanted to do, it was time now to build the actual parts. Of course, the two struts were of different size, so I ended up making two separate bushings to measure the alignment of the original one and to align the new one. The third one on the picture is the one for the stern tube. With the bushings finished, it was time to test the laser with the new strut. The next day I mounted the laser in the original strut and proceeded to measure the alignment as it was set from factory. Looking from inside the hole, it's obvious that the original alignment leaves a bit to be desired. I was sure I could do better. We'll see about that on part 2.